Good morning. My name is Rodrigues, and I will be presenting in the next minutes the experience and lessons learned by me and my colleagues regarding teaching computer graphics in a confinement context. We teach and research in the context of the Graphics, Interaction and Games group at the Faculty of Engineering of the University of Porto. In particular, we teach two CG-related courses in the Integrated Masters of Informatics and Computer Engineering. We have been doing this for a long time, some of us already for more than 25 years, and we frequently update our methods and contents. But never did we have to adjust as quickly as when the pandemic struck last year at the beginning of the second semester and threw us into the new reality. We therefore decided to share with you a bit of what was our experience in teaching CG before the pandemic and how we, as many of you, struggled to adjust to a remote model, which is not the same as a made-for-e-learning course in a very short period of time. Most importantly, we would like to share with you the approaches we took and the lessons we have learned in the process. To that end, we present a set of guidelines that we synthesize from our experience, hoping that they can be an additional help to those of you who teach CG, be it in a confinement context or not. We will start by outlining three main challenges we identify in teaching CG in general. The first challenge is CG's breadth and depth of theories and concepts, and the need to balance both, especially when considering students in early years of their masters. A high-level approach leads to an oversimplification, with students learning how to use tools but not really understanding core CG concepts. A low-level approach leads to a steep learning curve, frustration, and a difficulty to understand the applicability of the concepts. We therefore aim at a compromise in which we may provide an easy onboarding that engages students with increasing complexity and detail. The second challenge is the mapping of this balance into a class structure and the type of teaching resources required to support it. To this end, we believe that keeping a constant connection between theory and practice helps showing the concept's applicability and fosters exploration. We are therefore in favor of project-based learning, and we foster student autonomy with the support of educational libraries and code samples that facilitate onboarding for trying out concepts but enable looking under the hood to understand how things work. Finally, challenge number 3 is the assessment of students in general, and in particular considering the interactive and visual component of computer graphics assignments. We consider it important for the students to be able to develop their work in teams, as it helps develop several skills, but this brings some added challenges to individual assessment. Having support for that assessment in the libraries and tools used facilitates that process. So these challenges are continuously present in the two main CG-related courses that we teach, dubbed SEGRA and LAIG for computer graphics and Laboratory for Applications with Graphical Interfaces. The first is a 2-hour theory, 2-hour practice, 14-week course with a focus on fundamental theoretical concepts of computer graphics, in which the practical classes are used to see those concepts in action and explore them and how they are implemented. The second one is a 2-hour theory, 3-hour practice with more focus on the practical lab component with some more advanced topics for creating graphical applications. Theoretical classes in both courses follow a similar and, in a way, classical approach. In a normal in-person setting, the teacher presents the topics to an audience of around 150 students, providing practical examples and asking the students questions. The students also engage with the teacher on their own initiative, posing questions or commenting on the topics. Moodle is used for sharing content and for asynchronous communication via, for instance, discussion forums. The assessment of this theoretical component in computer graphics is based on 2 mini-tests done on Moodle with automated correction and a written exam consisting of both problem-solving and open-form theory questions. LAIG does not have an explicit theoretical component assessment as it's mostly practical. As for practical classes, they focus on applying the theory concepts on working applications through practical assignments for groups of 2 students. The group's progress is followed closely with in-class discussions and mentoring. In this process, not only the code is assessed and discussed, but also the interactive visual results produced. For supporting practical classes, we have developed in-house WebCGF, a WebGL-based JavaScript library created just for this purpose. It is characterized by having minimal dependencies, no specific setup requirements, and simplifying onboarding while still allowing to work at WebGL level. A major distinction between SEGRA and LAIG is the type of assignments. A SEGRA is a more introductory course. The first assignments are small, tutorial-like, each oriented to a given topic such as transformations or shading. As they progress, they become more goal-oriented, with less intermediate steps and thus more complex. After 5 assignments covering the main topics, they have a final project in which they are expected to apply what they have learned into creating a 3D scene combining rendering, interaction, and animation. In this scene, they have some predefined goals, but also freedom over many aspects of the scene such as objects, textures, animation, and other elements. Their practical assessment is focused on this final project. LAIG, on the other hand, is completely project-oriented, with 3 projects throughout the semester, the last of which consists of an interactive 3D board game that incorporates an AI component developed in logic programming courses. The assessment is done on a per-project basis as well as on an individual basis, in which students have to individually implement additional features over the group's code. This was how things worked before. However, in early 2020, the pandemic struck in Portugal, as in most of the world, and in mid-March, we were forced to move to a model of online remote classes overnight. A confinement was imposed on March 11th, and on March 12th, we were having the first remote classes. This was after less than 4 weeks of computer graphics classes in person. On the one hand, many components of the courses could cope with this model, being one of them the fact that we already used a web-based framework for the assignments. But on the other hand, there were others that would suffer significantly. The most immediate and common impact was on the student engagement and interaction, this both on theory and practical classes. But in particular, in practical classes, key elements such as visual assessment, project discussion, assistance, and overall follow-up of the projects became significantly challenging. Therefore, both classes had to be adjusted to try to keep student engagement. Regarding theory classes, these were conducted via Zoom, given the number of students, and the teacher made extensive use of the digital whiteboard and continued to engage with the students, posing and answering questions via voice and always keeping his video on. Students would either pose questions via voice or text chat, and the classes were recorded and made available to the students. Practical classes, due to their nature and challenges, had to adapt in a different way. An important element that had to be introduced was a tool for synchronous and asynchronous communication so that it could be used during practical classes for close follow-up, easy transition between groups, and for support and engagement after classes. To this end, we have chosen Discord, due to its features in terms of channel and role organization, and due to the fact that many students were familiarized with it. With it, we could foster the student engagement and interaction both during and after class. We could easily follow up on their projects and meet each group. They could share their screen for us to visually assess their work or assist with their code, and also in out-of-class follow-up meetings. The fact that WebCGF was a browser-based framework also made it easier for them to share online with us the working code, so that we could, for instance, test it directly in our browser without having to download or compile, etc. Later, in LAIG, we also introduced the use of standardized federated Git repositories, which greatly benefited coding assistance and assessment. We later asked the students to give us feedback about the remote class functioning, to which 47 out of 150 answered. Namely, we asked about general functioning and tools used, communication with teachers, and clarification of questions during and after classes. And we asked them to classify those in a Likert scale from 1 to 5. We also included 3 additional open questions regarding difficulties in understanding or following classes, asking for additional remarks or suggestions. We have received very positive feedback, getting an average above 4.3 on the Likert questions, and comments regarding the classes, saying that in some cases they were easier to follow online due to the silence of the audience, and that the use of the whiteboard and the availability of the recorded classes were quite helpful. On the other hand, half of the students stated that although they could follow the remote classes, they still preferred in-person classes, which is natural. Another more regular instrument adopted by the university are the per-course pedagogical questionnaires that students are invited to answer at the end of each semester. In this case, we compared the results of last year's SEGRAS edition with the ones from previous years. And these have shown that, in general, it received similar, if not better, grading by the students. This indicates that despite the conditions, the perception of the students in this edition was on par with the previous editions. In fact, in some cases, such as the appreciation and clarity and the evaluation process questions, the grades were higher in this last edition. We have therefore learned from that semester's experience, and in September we started the LAIG edition. However, at that point we were faced with slightly different setting. The confinement had been lifted, but there were strong limitations to classes. Namely, theory classes were still remote and practical classes were split in half. This meant that in a group of two, one student would attend in person in the room, while the other would be remotely, and in the following week they would swap. So we still had similar challenges in terms of keeping the remote half engaged and following up their work. We therefore continued the same model we had applied in Segra, improving a bit more the structuring of Discord channels. It was also at this point that we introduced the use of standardized Git repositories, managed by the teachers using federated authentication. This brought important improvements. We could have a more structured follow-up on project evolution, access easily to the code of the students to assist them, and get some additional metrics to support assessment. The results from the pedagogical questionnaires of LAIG were in line with those of Segra, which was again a very positive outcome for us. Based on this accumulated experience, we synthesized a set of guidelines that cover three main aspects: the course principles, the communication tools, and the development tools. Regarding the course, we consider that a two-stage approach with an initial first stage, more tutorial-based at first, and with incremental complexity, increases the students' autonomy, so they are ready for a second stage of fully project-based learning. With projects, they integrate multiple concepts and components, get a wider perspective of their interconnection, and grasp the importance of properly applying software development tools and techniques. This also fosters their autonomy, which is a key factor in the context of remote teaching, which, combined with facilitated peer exchange through the communication tools, creates an environment of collaboration and experimentation and a sense of accomplishment for the students who can help others. To support such course features, the communication tools are of utmost importance. In particular, having tools that support both synchronous and asynchronous communication is important for during and after class communication. It is obviously preferable if this can be integrated in the same tool, especially if they have well-structured communication channels. This structuring is only helpful if the interface facilitates navigation between different classes, groups, topics, so be sure to look into tools that help in that. Especially for courses as those related to computer graphics, where there is a need for visual assessment of results, it is very important that the communication tools allow for real-time screen sharing features. And finally, it is important that the adoption and onboarding by students and teachers is as broad and simplified as possible. So in some cases, that may be a deciding factor between two alternative tools. In terms of development tools, we have found that having a cross-platform browser-based framework provided simplicity in setup and flexibility in experimenting, testing, and accessing the running projects, with a minor performance impact for the types of projects developed. Using a standardized repository facilitates the follow-up, maintenance, access, and assessment of the students' code, and again leads them to practice other software engineering skills. Having federated authentication greatly simplifies the process. It also enables the use of continuous integration and delivery, which can be used for simplifying or automating the process of testing and deploying the projects, both for students and for teachers. We therefore conclude that, despite the challenge of teaching computer graphics that we all know, and aggravated by the communication gap enforced by confinement, the use of specific methods and technologies can help to cope with it. We have learned with our experience that course structure, communication tools, and development tools play a key role in this, and we hope that the set of guidelines we propose can be of help for those who teach computer graphics and face challenges similar to ours. Thank you for your attention.